So in this question, this is a core practical style question. It's one you should have completed in class. And you've given a method. What it wants you to do is explain what could be done after step 2. So they've measured out the acid and they're then adding the calcium hydroxide to neutralize the acid. And what you do after this point is you stir the mixture to help it react. So the thing they should have done is stir the reaction. Complete the word equation. So if you remember, the general equation for neutralizations is acid or base. So here we've got a base and an acid, and that always makes a metal salt and water. Okay, so in order to finish this off, you need to remember that if you have hydrochloric acid, the salts are chloride, and the metal first name is calcium. So here you have got calcium chloride and then obviously plus water. There's 2 marks in there, so you're getting 1 mark for the correct salt and 1 mark for telling us that it's water. Okay, which row shows the state symbols for the powdered calcium hydroxide and the acid? So calcium hydroxide is a solid, so it should have an S, and the acid is dissolved in solution, so that should have AQ, and the only one that matches that is option C. Okay, next little bit is the pH curve from this experiment. And it wants us to say what is the pH at the beginning. So if we zoom in here, the pH at the beginning, which is here, is going to be a pH of 1. So that's going to be pH 1. It says use the figure to work out the mass to neutralize this. Okay, so if we're going to neutralize it, we want the pH to be pH 7. So we take a line across, and then we bring the line down where it meets the graph. So that's to there. And that's going to be, using the scale on the graph, 0.7, and there's 2 squares, it's going to be 7, 4. Okay, and the last one is explain why the pH starts low and ends at a high value. Now the interesting thing here is 3 marks, so we've got to give them 3 bits of information. So let's do this first in the order it's asked us to. Why does it start off low? So we have a low pH because all we have present there are H plus ions. So we have got H plus ions in high concentration. We've got a lot of those, and therefore the pH is going to be low. The next point to get the 3rd mark is to tell them about this neutral point. So where we have neutralization, at this point we have got the concentration of H plus ions is equal to the concentration of OH minus ions. Okay, and the reason that works is because H plus ions react with OH minus ions, and that makes H2O water, and therefore we have a neutral solution. Okay, and then at the end of the experiment we have a high pH, and that is because here we've got OH minus ions are in excess, so we've got more of them than we have with the hydrogen ions. So at that point the pH is going to be greater than, bigger than 7. Okay, so 3 facts. The first fact is saying high pH at the beginning, low pH at the beginning because there's a high concentration of hydrogen ions. Then we've got neutralization where the H plus is equal to OH minus, that's pH 7. And then we end up going higher than pH 7 because the OH minus ions are in excess.